Okay, so I will put this back to a normal level, and I will insert the analog processes in the chain by enabling a head insert. So now everything is passing through analog chain, and everything is bypassed, so there is no difference. The difference is still the same as it was before. So if I engage the first EQ, can you hear that difference? Right. So this is one EQ. Second EQ. Compressor. Now we have two mixes, and they are at different loudness. And this is again the most important part in mastering. I have to adjust subjective loudness so the original will be as loud as my processed master. And this is something that AOSET is good at. You just press the button, it starts to blink, and you adjust an offset between those two. And the trick is to listen bass, not mid-range and high-range. Because we all know that our ear is more sensitive to mid-range, so if I boosted the mid-range and the high-range, and I will adjust the subjective loudness to the level of the mid-range, I will get it wrong. I should always listen to the bass energy, so the kick and the bass should have the same energy in the original and in the master to get the right proportion between processed and unprocessed mix. Otherwise, it will always sound that the processed master is thinner and has less bass, but actually it has the same amount of bass, only the difference is in the mid-range and the high-range. So always listen bass, presence, kick and bass especially, that they are the same loudness, and only that you can compare them A to B. Okay. So this is the difference now. This is more easier to hear. Okay. And in this whole process, I would probably use 2 more EQs. In this case, it was 2 more EQs and 1 additional compressor. So we cannot actually really compare in that way, but I will import the original master to the session, which was processed with everything, and then we will do an A/B between an original and the final track. So you can see that this train song head is going already into the clipping. I hope that you can see it. Okay, you can see it there. And the next thing I will do, will open digital distortion meter. And now we are actually not clipping the audio yet because we don't have any clipped samples. Now we do. So if we are looking at the RMS meter, this is basically -12 dB RMS, and if we go to K12 scale, we are pretty low for this kind of production. This should be around -8 to -9 dB RMS. Why it's not correct? Even because there are several devices missing in the chain, so the level is not correct now. So what do? I actually boost the gain on the train song compressor, and I'm hitting the converters and adjusting the level with the meter to a certain scale, to a certain level that I want to achieve. And in this case, I would say that this meter may be better. So this is RMS meter, and you can see that I'm around 12, which is pretty acceptable for this type of music. But one thing that you can see is the number of clipped samples that I'm producing with the limiter. So is this good or is this bad?
Until we don't hear it.
We don't care, exactly. It's not good, it's not bad, it's not important, because the same process is done inside the limiter, which I will show you now. The only difference is that this meter won't show it, because limiter has built-in brick wall limiting, and it won't show oversampling. Even the one from SSL, which is basically the best one, IXCM or something like that, it's oversampling meter, won't show clipped samples after the digital limiter, because digital limiter will hide them. And this is one thing that head can do very easily. If we just add a little bit of tape and pendle, and as soon as I turn this on, reset the meter, no samples are clipped. I turn the tape pentodes, the internal compression algorithm off, and we are clipping heavily. The joke is the clips are still present, just the head is not sending them to the digital output. So this is basically the same principle that limiter like Waves L2, I don't know, Xenon or whichever limiter works. It just doesn't show that it's actually clipping the audio. The meter won't show it, and this meter even has hidden clip detection, and these are the clips which will escape the head circuit. And that's why I insert Xenon afterwards in like really minimum gain reduction, and that means that I will remove even those. So you will check your master and you will say, great, it's really loud and nothing is clipped. But in reality, if we check this without the meter, you will see that I have like 70 samples clipped per second in this case. Average. Yeah, average is about 70 per second from 44,100, or in this case 88.200. So this is not that much, but we are achieving a level which will be pretty loud. So to be precise, we have to make a comparison, and that means that I will properly calibrate this level to the meter, and I will use one scale. Okay, let's say that this is okay and that I'm satisfied with this level.